Need help with the performance of your legacy mainframe applications? This is Joe Gullo with PathPoint Software speaking to you about handling application performance challenges. This is part one of a two-part series. Part one focuses on online application performance, while part two will address batch performance. If at any time you want to look at details more carefully, just pause the video so you can look at our screen captures in more detail. How well applications perform is an issue for every organization. An application is not considered performing well when user expectations have not been met. But what is being measured to determine application performance? As a user enters a business transaction, what is actually being measured is the time it takes for each input instance, that is, each time a user hits enter and gets a response back to complete the business transaction. When response times don't meet the service level agreement, it means that input instances are not meeting the SLA. When the user hits enter to start an input instance, there is a sequence that happens. The name of the CICS transaction is passed to CICS. CICS passes control to the application program, which starts the application processing path for that input instance. Each application program that executes on this path typically requests data from files, processes that data, then issues call statements to programs, and so on, until screen data is returned to the user. Where is most of the time spent on the input instance processing path? Let's take a closer look. There are two major components of input instance response time. Call statement time is when an input instance executes. Call statements are issued to invoke programs and to access files for data. The processing time for these call statements are a significant part of the response time of an input instance. Interim time is processing time that takes place between call statements. For example, when data is returned to a program after a call to a file, the program typically does some processing like editing and validation on that data. So input instance response time equals call statement time plus interim time. How can we capture this performance information? We use a tool called PathPoint from PathPoint Software to capture application processing path information, including performance information, for input instances as they execute on the mainframe. All you have to do is enter the business transactions you are working on, and PathPoint's mainframe component will capture the application processing paths for the respective input instances. The resulting file with the captured information is then loaded into PathPoint's PC component on your personal computer, where the captured information can be quickly viewed and analyzed using screen displays, and built-in reports. Let's review some main points before we move on. Let's do a quick recap. SLA or no SLA, you still need to figure out why an application is not performing well. It is the business transaction that is not performing, but you need to look at the input instances to see what actually went wrong. Call statement and interim time are the major components of input instance response time. And PathPoint Software greatly expedites performance analysis by dynamically collecting application performance information and providing a PC tool for looking at the information that's collected. Okay, let's move on then. We have several input instances that are not meeting their response time goals. Let's take a look at how PathPoint views input instances. This is a screen capture of the PathPoint PC component. Let's focus on 5 points. The application. Here we have a hierarchical view of the information that was captured for the CICS Universal Order Processing application. Major business function. One of the order processing's business function is called order entry. Two business transactions or scenarios are listed called multiple locations account and single order account. We see input instances for single order account. They are shown each with a unique identification number. Input instance 63 involves quantity. So let's look at the processing path for input instance number 63 by right-clicking and selecting Display Statements from the drop-down menu. Here we see a list of the call statements to programs and files that were captured in the sequence they were executed. Looking at the encircled columns from left to right, The leftmost column shows the input instance number, for example, 63, a sequence number on each call statement. The response time column that shows the elapsed time for each call statement, a time that is calculated from the start time and end time values that are carried for this statement. Other things to note are the program name, the call type like calls to programs, and calls to file types like DB2, VSAM, IMS, MQ, and so on. The statement location in the program, where in the program this call statement was issued, the call text itself, the status code that was returned, etc. Now, let's look at the business transaction in question. As shown in the view, we are going to focus our attention on the multiple locations account scenario. We first double-click on the scenario to get us to the performance view of this captured information. Here we see the multiple locations account business transaction at the top of the screen display, and the first 17 of its 53 input instances are shown below that. The column with the heading RES for response shows the response time for each input instance, and we can use this column to identify any input instances that are not meeting our SLA of 2 seconds or less. So let's sort these input instances by response to sending and see what shows up. In this sorted view, we see that the first 3 input instances are not meeting our SLA. To the right of the response column, we see 2 other columns that represent the components of the response time for an input instance, statement time and interim time, and their respective percentages. Let's see what these times mean. We know that each statement within an input instance has a start and end time. Using some basic calculations, PathPoint adds up all the call statement times and interim times for the entire input instance. So, for example, input instance number 26 shows a response time of 5.6 seconds, and its statement time, 0.04 seconds, accounts for less than 1% of the time, while its interim time, 5.5 seconds, accounts for most of the time, more than 99%. So let's investigate this statement by right-clicking and selecting the Display Performance Detail Interim Time options. Here we will find out where the greatest interim time occurs on this processing path. On the screen display at the top, we see that the interim time for statement number 2, 5.1 seconds, accounts for 93% of the total interim time, that total of 5.5 seconds. Sorting this display by sequence number, the screen displayed at the bottom of the screen shows that the first statement, sequence number 1, began a certain transaction, OE03, and CICS passed control to that initial program 3C. Looking at statement number 2, the interim time value, 5.1 seconds, tells us that it took 5.1 seconds before program 3C could issue a call, in this case a transfer control to the next program 4C. Here is where the majority of the time was spent, not in any calls to files, basically not for I/O. This 5.1 second delay could happen for several reasons. Maybe there was a delay in processing. The program 3C got control immediately and did a lot of upfront processing before passing control to 4C. Maybe that happened. Or perhaps there's a delay in loading the program, in which case we could talk to our CICS systems programmer and see if we can get some help in this case. The point here is that we were able to quickly identify where the time was being spent on the processing path and focus on the problem area to resolve the response time problem for this input instance. So let's look at another input instance that is not meeting our SLA. Looking at input instance 38, we see that the response time is 2.4 seconds, and that statement time, 2.339 seconds, accounts for most of this time. So let's right-click and select the Display Performance Detail Statements option to find where the greatest statement time occurs on the path. Here we see that statement 2 takes 2.337 seconds. It is a DB2 call statement, and it accounts for 99.1% of the total statement time. Let's drill down by double-clicking on the statement text to see why this statement is taking so long. Starting at the top of this screen display, we say that this is a relatively simple query. It selects several columns from a single table, the top account locator, and uses a single column, account name short, in the where clause. DB2 chooses a table space scan, a TSS, for an access path, so the whole top account locator table is being read sequentially. From the display at the bottom, we can see the columns for this table and the fact that it has 5 indices. When we drill down to see the columns referenced in these indices, and we find that there are no indices for the column account name short. The solution is to add an index for account name short. DB2 will select an access path that uses the index, like matching index scan, and the statement time will be reduced from 2.3 seconds to a sub-second time, and the response time problem for this input instance will be resolved. Again, knowing where to look is the key to quickly resolving application performance problems. If you are not familiar with DB2 access paths, you can generate this report for any DB2 statement on an application path. It contains the DB2 statement text, explain information together with scan statistics, table, and index information. All this information that a DB2 DBA would normally need to resolve the performance problem with this statement. The point is that here you are able to identify the statement causing the problem and see various means to resolve it. Gathering this performance information is easy to do with PathPoint software. The process is simple. You just enter the business transactions that you're working on and let PathPoint capture the paths they follow. You can quickly see if any of the input instances do not meet the SLA. If so, you can quickly drill down to identify and resolve the performance problem. This is extremely effective for looking at change requests before putting these changes into a production environment. You can quickly see if the changes you are making are going to cause a performance problem, and so you can take action beforehand. Please check back for more videos. Our video presentations are on our PathPoint YouTube channel. We're on the web at www.pathpointsquickstart.com. We're on Facebook, PathPoint Software. I'm Joseph Gullah, jgullah at PathPointSoftware.com. Please contact me for information on our PathPoint Quick Start service. Thank you.